A jet aircraft can travel 160 miles per hour in calm air. On a trip, the aircraft traveled 600 miles with a tailwind and returned the 600 miles against a headwind of the same speed. If the total round trip took 8 hours, then what was the speed of the wind? Let's begin by identifying our variable and organizing our data in a chart. Here we'll let W represent the speed of the wind. And we know distance equals rate times time, and there are two legs to this trip. Now, if the aircraft can average 160 miles per hour on calm air, then the aircraft's speed with a tailwind will be 160 miles an hour plus the speed of the wind. Now, the speed of the aircraft with a headwind will be 160 miles an hour minus the speed of the wind. The problem also states that the aircraft flew 600 miles with a tailwind. So we'll place a 600 here in for D. Now it flew the same 600 miles. It flew 600 miles against a headwind of the same speed. So we'll place 600 miles here for the return trip. Now finally it says the total round trip took 8 hours. And so we'll place an 8 here for the total of the two times here, the time spent traveling with a tailwind and the time spent traveling with a headwind. Now to get these times, we'll use the fact that distance equals rate times time, and then we'll divide both sides by the rate. If we do that, we can say distance divided by the rate equals the time. So in this particular case, we can say the distance traveled with a tailwind, 600 miles, divided by the rate, 160 plus W, will be the time spent traveling with a tailwind. Now similarly, we can say 600 divided by 160 minus W will be the time spent traveling with a headwind. Now it's this column here, this time column, that defines our setup. And so here we have the time traveling with the tailwind plus the time traveling with the headwind is equal to total of 8 hours. And this is our setup. To solve this rational equation, we begin by multiplying both sides by the LCD, which in this case is 160 plus W times 160 minus W. Now here we can see that multiplying by the LCD requires us to apply the distributive property here on the left side. For this first term, the 160 plus W will cancel and we'll be left with 600 times 160 minus W. Now multiplying times the second term, we can see the 160 minus W will cancel, and that'll leave us with plus 600 times 160 plus W. On the right, nothing cancels. And so we have this. Now at this point I noticed all these coefficients are divisible by 8. So let's divide both sides by 8 next. Now at this point we will apply the distributive property to both sides of this equation. And then collect like terms. Now at this point we can see that we can solve for W by extracting the square root. Let's subtract 25,600 on both sides, and then multiply both sides by -1. And we can see at this point we can take the square root of both sides or apply the square root property. In that case we'll get plus or minus 40 equals W. Since W represented the speed of the wind, we'll disregard the negative answer, and so the speed of the wind was 40 miles per hour.